Cool. Hello, today we're going to be discussing organic chemistry, specifically naming alkanes. As a review, you guys learned the basics of it, dealing with starting with carbons, adding hydrogens, and the hydrocarbons. We have the names meth, eth, prop, all referring to the number of carbons. So 1C, 2Cs, 3Cs, and then we have the structural formula. And obviously it goes from meth all the way to dec. So I want you to take time, pause this, and please write down these rules for naming alkanes. Excellent. Now that we're back, we can talk about this very specifically and go step by step. First thing, you're counting. And this is the biggest counting you have to do in this whole unit. Find and name the longest continuous chain. So let's do an example. Let's do this example below your notes. So this is example 1. Once again, take your time and write this down by pausing the video. Now that we're back, we have this example, and we've just got to find the longest continuous chain. So let's go down 1, 2, 3, 4, 5, 6, 7, 8. Just going down the straight chain, that is going to be the longest. So we know from the form that 8 is oct. So we're going to be doing something with a straight branch. So for me, I take this as a puzzle. So at this point, all of these are done. So I'm just going to write my name, the first part of it, oct. So I know in the blue square that is 8, and once I've done those 8, I don't have to worry about those again. So that's step 1. Step 2, identify and name the groups attached to the chain. So if it's not attached, if it's not part of that, for this case, this blue box, we've got to figure out what else is going on over here. So we have, they're called alkyl branches or extensions. I like to call them branches. And I'm going to circle, square, identify the different ones. The bottom one here, this is C with 3 H's. So just going to pick a shape and say that's going to be the triangle. Up here, the other thing that's not attached, 2 C's. All right. That's not the same as the one on the bottom, so I'm going to put another symbol around it, and that's going to be our second group or branch. Now, what are these branches called? How are we going to identify them? That is going to be, let's see here. We're going to name these branches. These branches are going to be referred to as alkyl groups. An alkyl group is a branch off the main chain. So technically it's groups of atoms that are formed when one hydrogen atom is removed for an alkyl group. So the R refers to the rest of the molecule, the rest of the chain. So for this instance, this CH3 So this area right here, CH3, that is an addition to it. You can either write it C with the 3 H's, or if you just want to write it in condensed form, CH3, that is fine as well. Now, since it does deal with just one C, it's still going to be referred to as a meth. So anything we refer to something that has one C, if it's a long chain, or if it's just a branch, it's going to be referred to as meth. Now, since this has a group connected to it, this R, so there's a chain. This might be The R might be octane, propane, butane. This group, now, since it's not part of the straight chain, and it's referred to as an alkyl group, it's a branch, instead of ending in ane, it ends in L, or YL. So let's go back and let's identify these. So, the red circle, so this is a branch because it comes off of the large one. So this is going to be referred to an ol. And we got to figure out, all right, 2 carbons, so that makes F. So this is ethyl. In the bottom, this once again is an ol. So it's an alkyl group. And since it only has 1 carbon, it is meth. So this is referred to as methyl. So we have methyl, we have an ethyl group, and the main chain is considered an oct. So now we just got to figure out how to put these in a way of naming it, in a logical way, I should say. So step 3 comes into it. It says number the chain consecutively, starting at the end nearest to the alkyl group, and then designate the location of each alkyl group by an appropriate number and name. Alright, so we've done the name already and number the chain consecutively. So what does that mean? So let's go over here and see your example. So if we start from left to right, this would be 1, 2, 3, 4, 5, 6, 7, 8. So at the first part of this, this triangle group, or as we know now as a methyl group, that would be carbon 3. If we reversed it and came from the left, we came from the right, it would be 1, 2, 3, 4, 5. So the first group would then be 5. So for this instance, we're going to go and make the smallest numbers, and the smallest numbers for these groups would be going 1, 2, 3, 4, 5, 6, 7, 8. Now, these are like a little address. So whatever carbon the group is connected to, that's how you name it. So this would be considered, that's on carbon 3, so 3-methyl. With the ethyl connected to it, it's on carbon 4, so it is referred to as 4-ethyl. So now we have them named. So 3-methyl, 4-ethyl, and oct. So how do we put this all together? So we've named it, we identified it, we've numbered it consecutively, we designate the location. So we assemble the name listing groups in alphabetical order. The prefixes di, tri, tetra, etc. used to designate several groups of the same kind are not considered alphabetizing. So the second part of number 5, we're not worrying about it because that doesn't interact with the one we're doing with. But we're assembling the name listing groups in alphabetical order. So as long as we know our alphabet, we should be good. So all together, it is going to be 4-ethyl dash 3-methyl. And there's no space between the L and the O. And since this is a single bond, all of these have a single line. There are no double bonds. They're alkanes. And alkanes always end in A-N-E. So altogether, this is 4-ethyl 3-methyl octane. The ane, once again, refers to single bonds. So there's only single bonds. The octane refers to there are 8. Methyl is a CH3 group. 3 is what carbon it's attached to. Ethyl is a CH2CH3 group on top. And 4 designate where it's actually located. So that's example number 1, 4-ethyl 3-methyl octane. So next one, let's try this. and I want you to try this on your own, and then come back and see how you did. All right, now that you've tried it, let's see how you did. First, we've got to identify the longest chain. I'm going over it. I see in the middle there are 5, so this is going to be our main chain. And if we know 5, that refers to as a pent. And since this only has only has single bonds, it's pentane. So we have the base of it, pentane. Then we have the 2 alkyl groups or branches. This is CH3 down here. And up here, this is CH3 as well. All right. So now we have, if we go back, CH3, this refers to a methyl group. And this also is a methyl group. So we've identified it, we've figured out the out groups, we've named the out groups, also known as alkyl branches. Now we've got to number it. Starting from left to right, it goes 1, 2. So 2 is the first one. If we go the other way, it's 1, 2, 3 before we hit the first branch. So it has to go 1, 2, 3, 4, 5. So this is pentane. There are methyls. So this methyl is actually 2-methyl. This is actually 3-methyl. So if you put it together, we could put 2-methyl, 3-methyl, pentane. But that's just being too long. That's going too long. So in the cases of being more than one methyl group or butyl group or any type of group, if there's more than one alcohol group, we can use prefixes. That's what Rule 5 is referring to. The prefixes di, tri, tetra are used to designate several groups of the same kind, but are not considered an alphabetizing. So even though you're using di, tri, tetra, the T, T, and D, they don't go into the alphabetizing. So for this, in this case, it would be, I'll bring this down, it would be 2, 3 dash di methyl pentane. So those are the first 2 examples of naming alkanes. Once again, I want you guys to pause this, try this on your own, and I'll come back. Welcome back. This is another long one. It looks menacing, but it's actually really easy. So if we start this, if we count how many there are, it's 1, 2, 3, 4, 5, 6. So that's an option if you go straight across. There are 6, so this would be hexane. But you can also do something else on here as well. If you go 1, 2, 3, 4, 5, 6, 7, 8. This is still, maybe it's not a straight chain, but if I were to go in a line, I could go all the way and continue my pencil without ever having to go backwards. So yes, this is the longest chain. It might have a bend in it, but I never lifted my pencil and went backwards. So this is our longest chain, which eliminates a majority of our name and our compound. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is an octane. This is 8. And even though it looked menacing, there is only one group. And we know already, we've done this before, this is a meth. This is one carbon. It's a branch, so it's all. So this is the methyl. Now we've got to figure out what numbering system we want to use. So once again, we could go, this is 1, 2, 3, 4, 5, 6, 7, 8. So our branch, if we're doing this, our branch would come at 5. Or if we go the other way, and we start from the right going to left, we'd be 1, 2, 3, 4. So this actually is the better route because we get to the methyl group faster. So we're going to be putting this in permanent. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8. So we designate this now for methyl, and we put everything together in alphabetical order. Now, since there's only one group, it's pretty easy. It's just going to be 4 methyl octane. So these are the examples we have for naming alkanes with both alkyl groups of meth and ethyl. So 3 examples. When we get to class, we'll have some more examples to go over. But at this point, have a great day, and thank you for watching.